Hello everyone, this is Mr. Kesnick making the video for this podcast. So I wanted to go through and review with you first on these to remind you what they are. So this is a parabola. And the translation equation for is y is equal to a, x minus h squared plus k. This one is a hyperbola, looks like hyperbola. And the translation form is a over x minus h squared plus k. This one is an inverse square. I'm going to be lazy and just write square, inverse square. And it's, whoops, I've got a problem with this one. This square isn't there. I was rushing. This one's the one that's got the square in it. X minus h squared plus k. Just like its name, inverse square, it's got a square in it. Okay, phew. This one's the absolute value graph. So y is equal to a, x minus h plus k. That's the half the sideways parabola. So wherever it starts, it's half a sideways parabola. So y is equal to, it's a square root graph is typically what you call it, a square root x minus h plus k. So that should be a reminder of what the equations are for these. This is something I expect you guys to memorize and expect that you have them on the tip of your tongue. Okay? Alright, so here you go. Domain. Domain is the numbers that you're allowed to fill into a problem. So it's your input. So if domain is your input, range is your output. Typically, when you have an equation like the ones I listed above, your inputs are your x's, and your outputs are your y's. So to say it a little bit better, a little bit differently, domain is the numbers you're allowed to fill into a problem without the calculators giving you an error. Range is the numbers you're allowed to get out. In other words, it's your answers. All right? Now, how do you find them? The first way I want to teach you guys to do this is do it graphically. Next week we'll look at doing it algebraically. So this graph will continue to get wider and wider and wider as it goes. Input is your x's. This is your x-axis. Oh my goodness, your x-axis. So you ask yourself, can the graph go as far left as it wants? Yes, it can. It will continue to widen and go as far left as it wants. Will the graph go as far right as it wants? Yes, it will. When that happens, I'm going to abbreviate domain with a D for domain and then a colon because I'm going to write the answer next to it. If you can go as far left as you want and as far right as you want, then it's all real numbers. How you abbreviate that is an uppercase R with the uppercase R written off of the left vertical piece of it. So it's two vertical pieces for the uppercase R, and then you're writing it off the left one. So that means all real numbers. So any number that doesn't have an I that you can think of, you can use. All real numbers. So let's try it with this one. Will this graph continue to go as far left as it wants? Yes, it will. Will the graph continue to go as far right as it wants? Whoops, I didn't mean to go across that. Yes, it will. Okay, but there's a gap in the middle. It never takes on the value of 0 because it's broken here. So x cannot be 0. This one, the inverse square, will it go as far left as it wants? Yes. Will it go as far right as it wants? Yes, it will. But in between, it never takes on the value, the x value of 0. So just like the hyperbola, the inverse square, the x cannot be 0. Okay, this graph, the absolute value graph. Will it go as far left as it wants? Yeah. Will it go as far right as it wants? Absolutely. It will go as far right as it wants as it traverses out. It will go as far left as it wants as it traverses out. There's no gaps in the middle, so your domain, again, is all reals. That's a colon, not equals. Sloppy colon. All right. How about I just erase it and start over? That's embarrassing. Okay. All reals part was okay, but the domain part, colon, all rails. Okay. Okay, this is half a sideways parabola. It starts there and continues off to the right. So can you go as far left as you want? No, you can't go as far left as you want. So x has to be greater than or equal to where it starts, and it starts at 0. Okay? Range. Can you go as high as you want? Can you go as low as you want? Okay, those are the questions you ask to get your range. So range. Can you go, does this graph continue to go higher and higher and higher? Yes, on both sides. It continues to go higher and higher and higher. Can you go as low as you want? No, I can only go as low as 0. So your y values, your range, is y is greater than or equal to 0. Okay, the hyperbola. Does it go as high as it wants? Yes. Will it go as low as you want? Absolutely. But as you move up to down, there's a gap. Where is that gap happening? It's happening at 0. So y cannot be 0. It never takes on the y value of 0 because of the asymptote that's right here. It never has a y value of 0. Okay, range for the inverse square. Will it go as high as it wants? Yes, on both sides. Will it go as low as it wants? No, it won't. It'll only go as low as that asymptote that's here. The asymptote is at 0. Will it ever touch the asymptote? No. So y, y has got to be greater than 0 because it's from that asymptote up, and it never takes on the value of 0. Okay, range on this one. Okay, will the graph go as high as it wants? As you traverse out to the right, it will go as high as it wants on both sides. Will it go as low as you want? No, it'll only go as far down as 0. So y is greater than or equal to 0. Okay, range. Can you go as high as you want? Yep. As you traverse out to the right, the graph will continue to go higher and higher. Can you go as low as you want? No, it'll only go as low as 0. So y is greater than or equal to 0. Excuse me. Okay, so down here on these, what you need to do is a quick sketch, and then tell me the domain and the range. The vertex is at -4, +3. -4, +3. The value of a is negative, so that tells you the graph is opening down. There's a quick sketch of the parabola. Can you go as far left as you want? Yes. As far right as you want? Yes. So the domain is all reals. 1 second, I get a drink. Thank you for that. Okay. So the range. Can you go as high as you want? Yes. Oops. The guy spoke too quickly. No, you can't go as high as you want. You can only go as high as that point. Well, that coordinate again is -4, 3. You can only go as high as the y value of 3. So y has to be less than or equal to 3. Okay. This one. It's a hyperbola. The asymptotes are happening 5 units right and 3 units down. It turns out it's the same for this one too. So I'll just go ahead and do the asymptotes for both of them. So 5 right and 3 units down are your 2 asymptotes. Let's go blue. Okay. It's a hyperbola. The value of a is positive, so it's going to sit in the positive orientation. So it's sitting here and here. So the domain, can you go as far left as you want? Yep. I can go all the way out left I want. Can you go as far right as you want? Yep. As far right as I want. But as you move left to right, there's a gap. Where is that gap happening? It's happening at 5. So x cannot be 5. Range. Let me scoot that down just a little bit. Okay, range. Can you go as high as you want? Yep, this will continue to go up. Low as you want? Yep, that'll continue to go down. But as you move up to down, there's this gap here. Where's the gap? The gap is at -3. So your range is y cannot be -3. All right, this one. Okay, it's a negative version of the inverse square. So it's going to sit in the negative orientation of the inverse square graph. So that's here, and here, and here, and here. Okay, can you go as high as you want? Oops, I'm getting ahead of myself. Domain first. Can you go as far left as you want? Yes. As far right as you want? Absolutely. But as you move left to right, there's a gap here. Where's the gap? The gap's at 5. So x cannot be 5, just like it was at this one, because of the vertical asymptote. It can't touch the vertical asymptote as you move left to right. Range. Can you go as high as you want? No. This asymptote is preventing it from going higher than or including -3. But it can go as low as it wants, so y is less than or equal to -3. The absolute value graph. It's starting at the coordinate -3, -2. -3, -2 is where it starts. The value of a is positive, so it's the upper version of the graph, the positive version of it. So your domain, can you go as far left as you want? Yes. As far right as you want? Absolutely. There are no gaps or asymptotes in between. So your domain is all real numbers. Range, can you go as high as you want? Yes. As low as you want? No. That coordinate is -3, -2. I can only go as low as -2. So I can go greater than it or equal to, because that's not an asymptote that it's bumping into like it was on this one. Schneid, can I have a mistake on the last one? That can't be equal to it because of, that's 2 mistakes in this thing. Good grief. This is bumping into an asymptote, so it can't take on the value of -3. I'm so sorry. Okay, so back to this one. It doesn't have an asymptote that it's bumping into, so I can't include it. Okay, that's embarrassing. But I caught the mistake, so, all right, here goes. It's a square root graph. It's starting at 3, 7. 3 units over, 7 units up. A is positive, so it's the upper half of a sideways parabola. Your domain, can you go as far left as you want? No, I can't. I don't begin until the coordinate 3. So x has to be greater than or equal to 3. Range, can you go as high as you want? Yep, it continues to go higher, but I can only go as low as 7. So y is greater than or equal to 7. All right, so in your homework, when you see these problems, I want you to do a quick sketch. So let's go, I don't know, we'll do this one. It's starting at 4, 5. 4 over, 5 up. A is positive, so it's the upper half of a sideways parabola. And then tell me the domain and range. Okay? On these ones up here, I don't give you the equation, and that's okay, because your first attempt at domain and range is doing it graphically. So just look at it and ask those same questions. Can the graph go as far left as it wants? Can the graph go as far right as it wants? Are there any gaps in between? This one is no, so your domain is all real numbers. Range. Can you go as high as you want? Yes. As low as you want? No. And I have no information here to give you on whether that is an asymptote. So we're looking to hit the easy button. Assume that is not an asymptote. There's no reason to believe there is one there. So assume you can have the value of 0. So y has to be greater than or equal to 0. It has an equal sign there. So that's all you're doing on these. It's just looking at the graph, telling me the domain and range. One note on this one, these aren't asymptotes, but it is trapped between the value of 1 and -1. it will continue to do this forever. Okay? So it's trapped between those. That's all I'll say about that. All right, I want you to try it. All right, that's your homework, and thank you for your time.